Okay, we'll now look at this case where a block of mass, 10 kg, is on a smooth plane that is inclined at 30 degrees to horizontal. We are to calculate the value of the force P that pulls this block up the plane if the block accelerates at 2 meters per second squared, decelerates at 2 meters per second squared, or moves with a constant speed up the plane. Okay, first of all, you can see there I've already drawn the free body diagram of this block of mass, showing all the forces acting, including the force P. And then I also included the component of the weight, mg, that acts down the plane and also parallel to the plane. And you can see the normal force, Fr, that acts perpendicular to the plane surface. And then this is the angle of inclination, which is also equal to this angle. In my last video, I showed how to, resolve this the width mg into two perpendicular components. The component of mg, that's the weight of the block, down the plane is mg sin theta. The other component that acts perpendicular to the plane is mg cos theta. Now, this component tends to balance the normal force that acts from the surface of the plane. So these two forces are balanced because there's no motion in this direction. We only have the block moving along the surface of the plane. So that let's look at the first question. The block accelerates at 2 meters per second squared. Okay, let's see. This is the direction of motion because this force P pulls this block up the plane. And in that case, the resultant force on this block is given this positive because it's acting along the positive x-axis. mg sin theta is acting along the negative x-axis. And also recall that this is a very smooth plane. It means that the effect of frictional forces are negligible, are ignored. So the resultant force on the mass m is P minus mg sin theta, which equals ma. Now you have to find the value of force P. Therefore, force P equals mg sin theta plus ma. Okay, and then the mass of the block is 10 multiplied by 9.8 sine 30 plus the mass of the block 10 times the acceleration here is 2. So with this, we can quickly find the value of force P that is responsible for the motion of the block of mass up the plane. Okay, get your calculator ready there. That gives me 10 times 9.8 times sine 30, which gives me 49, plus 10 times 2, that gives me 20. So the value of force P is 69 Newton. Okay, so that's the force P that pulls it up the plane. Now we have to also find the value of force P. That's the B part of the question. Suppose the block decelerates. So go back again and write down the equation for the resultant force acting on the block. That is P minus mg sin theta equals ma. Now, since the case of the block decelerating, what happens in that case? Given that case, it means that I'm going to do this, the acceleration becomes negative because deceleration is negative acceleration. So the value of force P this time around is minus ma, that is with this, bring this to this side, plus mg sin theta. That gives me minus 10 times 2 plus that's deceleration, that's 2. Then that gives me again 10 times 9.8 times sine 30. So this gives me minus 20 plus multiply this by this by this will give me 49. So the force P this time around is equal to 29 Newton. That's the difference between 20 and 49. And this the last case said if the block moves with a constant speed means that the resultant force on the block is zero and its acceleration is zero at constant speed, because for constant speed is the resultant force, which is the difference between the force P and mg sin theta, equals zero. Recall that when a body moves at a constant speed, it does not accelerate, especially when it moves along a straight line. It has no acceleration. So its acceleration is zero. That makes A zero, and everything on this side becomes zero. So what you have is P minus mg sin theta is equal to zero. That gives me force P as equal to mg sin theta. My mg sin theta evaluated at that time as 49. So my force P is 49 Newton. So that gives the value of the force P in that situation.